Welcome to the Avionics training facility. ATF uses sophisticated, real-time, interactive, three-dimensional graphics to represent a synthetic Tornado aircraft in all the fidelity required to fault diagnose the avionics systems of the entire aircraft. The system is currently in use at the Tornado Maintenance School at RAF Marham and now replaces their physical mock-up simulators. Up to 8 students may be trained simultaneously, all of them controlled and monitored via a network by the instructor's workstation. Here, we see the instructor selecting a student and configuring a scenario in which the student can train. The instructor has a choice of which aircraft build to use and which faults to apply to the avionics subsystems. Here, we see a fault being applied to the Radalt subsystem. The instructor can choose to apply as many or as few faults as required. A briefing is given to the student detailing the objectives of the exercise and, depending on the type of exercise, symptoms of the fault or faults. The students are given complete free play and are able to make both correct and incorrect fault diagnosis. Three-dimensional interiors of both the navigators and pilot's cockpits are available to the student. The student may also inspect the exterior of the aircraft. Each of the discrete avionics units, known as line replaceable units or LRUs, can be extracted and examined in 3D. There are over 300 such units within the system, all of which were recreated from a set of over 2,000 photographs taken by virtual presence due to an absence of CAD data for this aircraft. This amounts to over 200 megabytes of textual information for the entire aircraft. Each LRU is fully interactive, allowing the student to flick every switch, press every button, and set every dial. In the bottom right-hand corner of the screen, simulation time is shown. This time reflects not only the time spent diagnosing the current fault, but also the time needed to physically remove, replace, refit and test an LRU in order to bring the aircraft back up to flight worthiness. A Zoom 2 facility aids navigation by allowing a student to quickly align their viewpoint with a particular LRU. The Avionics training facility runs on standard off-the-shelf PC hardware. The version commissioned by the RAF uses a triple-pipe PC to generate 3 virtual views of the aircraft, each displayed on a separate VDU. Exercises can be allocated to individual students or to a team of 2 students, working together across the network on the same virtual aircraft. Both on- and off-ground operation can be simulated. There are over 50 panels and hatches on the aircraft exterior, each of which can be opened or removed to reveal the LRUs behind them. Since the introduction of this system, the RAF have reported a reduction in training time from 11 weeks to 9. Students are now able to grasp key training concepts in almost half the time it took using traditional methods. During an exercise, the instructor can snoop on any student in order to monitor their progress and communicate instructions to the student via an audio network. We now see the student powering up the aircraft in order to check the functionality of LRUs in the navigator's cockpit. After the student has powered up the aircraft, the virtual LRUs take on the functional characteristics of the real working ones, unless of course they have a fault applied to them by the instructor. As well as knobs, switches and buttons, the LRUs also have working dials, lamps, LED and vector displays, and audio alerts. Notice how they activate as the student interacts with them. The green vector displays accurately mimic the functionality and appearance of the real-life versions and are generated on the fly, as in the real aircraft. We are now looking at the Radalt indicator LRU. The student decides to test this unit with the Radalt test equipment. This equipment sits outside the aircraft and sends dummy height information to the Radalt, allowing the maintenance engineer to check if it is giving accurate readings. As the student selects different preset heights on the test equipment, we notice that inside the aircraft the Radalt indicator is responding. It is now up to the student to decide if the unit is faulty. If so, then the unit can be replaced with a new one and the Radalt subsystem tested again to confirm the suspected faulty unit was the correct one to replace. There are over 30 different pieces of test equipment for the student to utilise in order to diagnose faults. After an exercise has been completed, the instructor can view a log file of the student's activity to help in the assessment of their approach to the exercise. The Avionics Training Facility by Virtual Presence.